Welcome to the Maths Explained channel. In this video, I'll be going through a GCSE Higher Edexcel exam paper. This is from 2018. This is paper 1, sat on the 24th of May. And as always, paper 1 is a non-calculator paper. One way you can use these videos is to pause the video on each question and give it a go and then watch the solution to check you did it correctly. Or you can give the entire paper a go and then check the specific questions you might be having trouble with. So let's get into the questions then. Question 1a says work out 2 1/7 plus 1 1/4. These are the types of problems you do not want to lose any marks on. You don't want to make any silly mistakes. And one way you can do this is to do the question in two different ways. So that's what I'm going to go ahead and do, solve this in two different ways. And then as long as I get the correct answer, I can be fairly confident that I have done it correctly. So the first way you can do this is to write this as, this is the same thing as 2 plus 1. So the whole number parts of these mixed fractions, 2 plus 1, and then a seventh plus a quarter. So this is the same thing as 2 1/7 plus 1 1/4, 2 plus 1 plus a seventh plus a quarter, and then all I really need to work out is this seventh plus a quarter. For that, you need the lowest common denominator of 7 and 4, and that's going to be, 7 multiplied by 4. There's no other lower one than that. So 28. So I need to multiply this one by 4. So we get 3 plus 4 on 28 plus 1/4 multiplied by 7. That's 7 on 28. And then we've got 4 plus 7. That's 11. So this is going to work out to 3 and 11 on 28. Okay, so that's my first method of solving this. Then you can also change these into improper fractions and add them that way. So this 2 1/7, that would be 2 times 7 is 14 plus 1 is 15 on 7 plus 1 times 4 is 4 plus 1 is 5 on 4. And then you still need to find the same denominator. It's still going to be 28. So I need to multiply this one by 4. 15 times 4, that's 60 on 28 plus 5 on 4 multiplied by 7, that's 35 on 28, and 60 plus 35 is 95 on 28. And now I want to check these are the same, so you could either change this into an improper fraction or change this to a mixed fraction. I might go with this one because I think multiplication is easier than division. So 3 times 28, because it's a non-calculator, I might just really make sure I'm getting this correct. So 8 times 4 is 24. 2 times 3 is 6 plus 2 is 8. 84 plus 11 is 95. So I also get 95 and 28 over here. Okay, so that's going to be my final answer, 95 on 28. And this way was kind of like my double check. Now you have to kind of balance if you actually want to do all of this extra work in an exam. Do you have time for that? And it may be a trade-off. If you're the type of person that makes those small errors or those silly mistakes, as they say, maybe this is a method that can help you avoid those silly mistakes. But of course you do have a time limit, so that's something to consider as well. Okay, on to the next question. Part B says work out 1 1/5 divided by 3/4. Give your answer as a mixed number in its simplest form. Okay, so for this one, we need to convert this 1 1/5 to an improper fraction. 1 times 5 is 5 plus 1 is 6. So 6 on 5 divided by 3 on 4. And then you need to remember that dividing by 3/4 is the same as multiplying by 4/3. And a useful acronym to remember this is KFC, keep, flip, change. So you keep the first fraction, you flip the second fraction, and then you change the sign. So this is 6 on 5 multiplied by 4 on 3. And then this becomes a lot easier, right? You just need to multiply the numerators and denominators. Also, consider cancelling if you want to make the multiplications easier. Sometimes you can have really large numbers here, but you can cancel anything in the denominator with anything in the numerator as long as you're multiplying. So this 3 and this 6, they have a common factor of 3, so I can cancel that. So 6 divided by 3 is 2, 3 divided by 3 is just 1. So then this becomes 2 times 4, which is 8, and 5 times 1, which is 5. So final answer there, 8 on 5, except it says give your answer as a mixed number in its simplest form. So a mixed number is like this, where we have a whole number part and a fractional part. So we need to change this improper fraction to a mixed number. 5 goes into 8 once with 3 left over. So that numerator in that fraction, remember, is the remainder after we divide by the denominator. So actually my final answer is 1 and 3 on 5. And that was question 1 for 4 marks. On to question 2 then. In a village, the number of houses and the number of flats are in the ratio 7 to 4. The number of flats and the number of bungalows are in the ratio 8 to 5. There are 50 bungalows in the village. How many houses are in the village? Okay, so if they tell us how many bungalows are in the village, we can use these ratios to work out the number of houses. Because they tell us the number of flats, the number of bungalows is 8 to 5. That means that there will be 80 flats, right? So let's go ahead and do a bit of, or write down a little bit of working. So flats to bungalows. Bungalows is 8 to 5. And an equivalent ratio such that the number relating to bungalows is 50. If I multiply this by 10, I would get 50 on this side, and multiplying the whole thing by 10, I get 80 to 50. So if I have 50 bungalows, that means I have 80 flats. And now let's consider the ratio of houses to flats. So houses to flats, this is 7 to 4, and we need to find an equivalent ratio such that the number relating to flats is 80, because we know there are 80 flats in the village now. That's what we worked out in this part. So what can I multiply 4 by to get to 80? That would be 20. So multiply by 20 here, and 70 multiplied by 20 is 140. 140 to 80. So that tells us then that the number of houses in the village is 140. So for 3 marks there, final answer 140 for question 2. On to question 3. Renee buys 5 kilograms of sweets to sell. She pays £10 for the sweets. Renee puts all the sweets into bags. She puts 250 grams of sweets into each bag. She sells each bag of sweets for 65p. Renee sells all the bags of sweets. Work out her percentage profit. Okay, so she's bought 5 kilograms of sweets and she paid £10. How much is she making? That's the question. Well, I guess the first thing to work out is how many bags is she going to make out of 5 kilograms. If she puts 250 grams in each bag, how many lots of 250 grams goes into 500 or 5 kilograms, sorry. Well, remember 5 kilograms is 5,000 grams, and then we need to divide that by 250 grams, and that will give us the number of bags. So 250 goes into 1,000 4 times. That's like 25 into 100, right? So that means we're going to get 5 lots of 4. So this is going to be 20 bags of sweets. So we could write 20 bags of sweets she's going to sell. Okay, and then she sells each bag for 65p. I'm going to introduce a bit of terminology here. You don't have to use these words, but I think it's worthwhile to learn what they mean. So the first one is revenue. Revenue is the total that you make regardless of what you've spent. So we're not considering the £10 she's spent already. We're just considering what she's made from selling these bags of sweet. That's revenue. So this is going to be 20 times 65p. 20 times 65, well, that's like 2 times 65, that would be 130, but then we add a 0 on the end because this is 20, not 2, so this would be 1,300. And remember, this is pence, so 20 lots of 65 pence, 1,300 pence, which is, of course, £13. Okay, so her revenue is £13, and then we can say her profit then is equal to her revenue take her expenses. Okay, again, you don't have to write all of this, but I think it's worthwhile to know what these words refer to. So revenue take expense is 13, take £10, that's £3. So her profit is £3. And then remember, go back to the question, always make sure you're answering the question. It says work out her percentage profit. Her percentage profit is the profit on the original price. So it's the percentage out of what you originally spent. So we can say percentage profit is equal to the profit divided by the original price. So this is equal to £3 on £10, what she originally spent, and 3 on 10 is of course 30%. Okay, so final answer there, 30% for question 3 for 4 marks. On to question 4 then. Question 4 says a cycle race across America is 3,069.25 miles in length. Juan knows his average speed for his previous races is 15.12 miles per hour. For the next race across America, he will cycle for 8 hours per day. And part A says estimate how many days Juan will take to complete the race. Alright, firstly let's summarize the information they give us. So they tell us the average speed, or his average speed. So let's write that down. His average speed is 15.12 miles per hour. Okay, that kind of looks like a 6. That's meant to be a 5. And also, we know the distance that he's riding in this race is 3,069.25. So let's say distance is 3,069.25 miles. And we are trying to estimate how many days Juan will take to complete the race, given that he rides for 8 hours per day. So this is like the time taken, right? So we've got speed and distance, and we're looking to calculate time. So you should know that time is equal to the distance divided by the speed. And the important word in the question is estimate. We don't actually have to work this out. We're not going to divide 3069.25 by 15.12. That'll take quite a while. We want to round these off to something. So a realistic estimate for me for the distance would be to 1 or 2 significant figures. You could either round this off to 3,000 or 3,100. I think both would be okay. I'm going to go with 3,000 because it's easier. And then for 15, rounding that off to 1 significant figure, I think it changes it quite a lot. So rounding this off to 2 significant figures seems to make more sense. So rounding the average speed off to 15 seems to me like it should give a fairly accurate estimate. Okay, so then I'm doing 3,000 divided by 15, which is much easier than this divided by this, and it's going to give a fairly close approximation. So 30, you can think of this as 30 divided by 15, and then add 2 zeros. 30 divided by 15 is 2, and then add those 2 zeros, 200. So my time then is 200, and the units here, we're talking about miles and miles per hour, so this is going to be 200 hours. And we need to work out how many days. So I need to convert this to days, considering the fact that he's riding 8 hours per day. So basically just divide this by 8. Well, if 25 goes into 100 4 times, then 25 is going to go into 200 8 times. So this is going to be 25 days. Okay, so my estimate for the number of days to complete the race for Juan will be 25 days. And let's just consider if you did say this to 2 significant figures as well. So we'd get 3,100 divided by 15, which would be what? That would be 200. And then 15 doesn't go into 100 evenly. So it would be, so then we'd have to round off that answer actually. So 15 goes into 90 6 times. So then we'd get what, approximately 200 plus 6, so 206. Again, that's rounded off. And then if we divided that by 8, we would actually get 25. So 6 on 8 is like 3/4. So this would actually round off to 26. And I believe that is also in the mark scheme. So 26 or 25 would be fine for your answers there. But it just depends on realistic estimates of these numbers. Okay. But please check the mark scheme for the range of different possible answers for that question. Part B says Juan trains for the race. The average speed he can cycle at increases. It is now 16.27 miles per hour. How does this affect your answer to part A? Okay, so for me, I would probably still round this to 15. so to the nearest 5, although you may round that to 16, in which case then his time would decrease, of course, because if he's going faster, he can finish the race in less days, in less time. So depending on how you want to approach this, or how you did part A, you could either say less time or it does not affect my answer. So that's what I'm going to say. It does not affect my answer to part A. I would still round 16.27 to 15. Okay. So 2 possible answers to that one. And that was question 4 for a total of 4 marks. Question 5 says, here is a solid square-based pyramid, VABCD, and we're given a diagram, and then the front view is indicated. The base of the pyramid is a square of side 6 centimeters. The height of the pyramid is 4 centimeters. M is the midpoint of BC, and VM equals 5 centimeters. Part A says, draw an accurate front elevation of the pyramid from the direction of the arrow. Okay, so if we're looking head on to this pyramid, you do not actually see anything behind there. All you would see is this front face. If you're looking straight on from the front. So all we actually need to draw here is a triangle with a base of 6 centimeters and a height of 4 centimeters. And then we're done. So on this grid, let's draw a line 6 centimeters long. You could start anywhere. Let's just start here. 1, 2, 3, 4, 5, 6. And then we go up in the middle to 4 centimeters. So 1, 2, 3, 4. Up to here. And then we are done. So there's the front elevation. Part B says, work out the total surface area of the pyramid. Okay, so let's draw now a net of this shape. So if we unfolded this pyramid, or we took the sides and split them open, if you like, well, we'd have the base, which is a square because it's a square-based pyramid, of course. So the base is a square, and then you have the sides unfolded to the sides. So they would all be triangles. So this is the net of this 3-dimensional shape. And you can imagine if you fold these sides up, you have the pyramid. Okay, so now let's draw in the dimensions. Remember again, the base was 6 centimeters. The height was 4 centimeters, and this side here, this diagonal side, is 5 centimeters. So where would they fit in? Well, the 6 centimeters, that would be the sides of the square. What about this 5 centimeters? That's actually the height of these triangles on the side here, right? That are unfolded. So this is different to the height. And it's difficult to kind of describe, why that is if you don't see it. But this one here is 5 centimeters. This side length of the square is 6 centimeters. And then the height of the pyramid comes in when all of these sides fold in. So that actually is not going to really impact our surface area. These are the important dimensions. Okay, so firstly, the area of that square is 36 centimeters. So I guess we should write some of this down. So the area of the base of the pyramid is 6 squared, is 36 centimeters squared. The area of this triangle and all of the other triangles will be the base. So let's write the area of triangle is the base, which is 6, multiplied by the height, which is 5, divided by 2. And that's 30 divided by 2, that's 15 centimeters squared. And then we've got 4 of those. So 4 times 15, that's 60. So then the total surface area is equal to 36 plus 60. 36 plus 60, that's 96 centimeters squared. Okay, so final answer there for part B, 96 centimeters squared. Okay, on to question 6 now. Okay, question 6 says a pattern is made from 4 identical squares. The sides of the squares are parallel to the axes, and they give us a diagram here, and the 4 squares lined up like that. Point A has coordinates 6, 7. Point B has coordinates 38, 36. Point C is marked on the diagram. Work out the coordinates of C. Okay, so points A and B are marked on the diagram, and we need to work out C. And they tell us that the sides of the squares are parallel to the axes. That's important because that's what actually allows us to solve this problem. So for the squares, they're all identical squares, so they're all going to have the same side lengths. So we can firstly look at these x coordinates, 6 and 38. Because the distance between these two coordinates, between 6 and 38, so if you imagine you drew a line from these points A and B down to the x-axis, this would be 6 on the x-axis, this one would be, let's try to get this straight, this would be 38 on the x-axis, and this distance is divided by 4 sides of these squares, okay, because all of these squares are just touching on the corners. So this distance from 6 to 38 is split up by 4 squares, 4 equal side lengths. So we can work out the side length of the square by using that idea, right? The distance between 6 and 38, well, 38 take 6 is 32. So we could say the distance between A and B equals 38 take 6, which is 32. 32. And that's along the x-axis. Okay, and then we can divide that by 4 to get the side length of the square. So the side length of the square is equal to 32 divided by 4, which is 8. And so now going back to the diagram, we have the side length of the square is 8. How can that help us to find C? Well, looking at C, it's on the corner of this square here, and if we go down from the y coordinate down 2 side lengths, we get to C. Okay, so if you go over to the y axis from B, let's just draw a straight line like that. This is 36 on the y axis, and then C is somewhere here, and in between those 2 points is 2 side lengths, 2 equal side lengths of the square. And we already know, we've already worked out the side length of the square is 8. So this distance is 8, this distance is 8. Therefore, we go 16 down on the y-axis. And this would be 36 take 16. That would be 20. Okay, so we have the y-coordinate of C. So let's go ahead and write that down. So y coordinate of C is equal to 36 take 2 times 8. I'll just try to be really clear with my working out. That's 36 take 16, that's 20. And then the x coordinate, maybe you can already see how we can work this out. We could either go from 6 across 2 lots of 8, or we could go down from 38. And let's do it both ways to make sure we're getting it correct. So 6 plus 2 side lengths, 6 plus 16, that's 22. And then 38 take 16 is also 22. So we can be fairly confident that C is at 22 on the x-axis. Okay, so the x-coordinate is 22. So my coordinates then are 22, 20 for a final answer for question 6. Okay, on to the next one. Question 7 gives us a diagram with a triangle, and it says shape T is reflected in the line x equals -1 to give shape R. Shape R is reflected in the line y equals -2 to give shape S. Describe the single transformation that will map shape T to shape S. Okay, let's firstly draw in these shapes, R and S. So we reflect it in the line x equals -1. That would be here, right? That's a vertical line at x equals -1. Every point on that line equals -1. So if we reflect this shape in that line, well, this point is 1, 2, 3 away. So we need to go 1, 2, 3 to this side. And this point is 1, 2 away. So that would be here. And this point is 1, 2, 3, 4 away. So that would be here. Okay, so that's shape R, as they labeled it. And then we need to reflect that in the line y equals -2. Okay, which is here. That's a horizontal line going through -2 on the y-axis. And that is reflected. So this point here is 1, 2, 3 away. So that would be 3 on this side. Same for this one. And then this one is 5 away. So that would be down here. Okay, and then we have the shape S. And the question is, what single transformation would get us from T to S? Well, it's going to be some kind of rotation, right? Because this is orientated differently to T. It's upside down. Okay, so we've rotated it 180 degrees. And the other question is, what point have we rotated it around? And maybe you can see this already. But if you look at this corner here, it's 1, 2, 3, and then 2 across to this point. And then 1, 2, 3 up and 1, 2 across to this point. It's actually rotated around where these two lines intersect. And this is actually always going to be the case. If you reflect a shape in a vertical line and then a horizontal line, you can also describe it as a rotation around where those two lines intersect, a 180 degree rotation. So this point here is at -1, -2. So to answer the question, we can say rotate 180 degrees about -1, -2. And of course, the direction of rotation doesn't matter. The other thing is, you can also say it's an enlargement of -1. That's kind of the same thing as saying a rotation of 180 degrees. But this would be my answer for this question. Rotate 180 degrees about -1, -2. And that was question 7 for 2 marks. Question 8 says the perimeter of a right angle triangle is 72 centimeters. The length of its sides are in the ratio 3 to 4 to 5. Work out the area of the triangle. The first thing I usually do when trying to solve questions like this is to draw a diagram and then represent the information they give me on the diagram somehow. So they tell me that the total perimeter is 72 centimeters and the side lengths are in the ratio 3 to 4 to 5. Well, I need those side lengths to add up to 72. One way you can work out the side lengths is to divide this ratio up into the 72 centimeters. So you could do 72 divided by the total parts in this ratio. That's 3 plus 4 plus 5. That's 12. So 72 divided by 12. That actually goes evenly. 12 goes into 72 6 times. So each part in this ratio is worth 6 centimeters. So 3 times 6, that would be 18. And it's pretty clear I haven't drawn this to scale. But when you're doing rough diagrams, it really doesn't matter if they're accurate or not. It's just to get an idea of the question. Anyways, 4 times 6, that's 24. And then the other side, 5 times 6, that will be 30. Okay, so I have my side lengths of my triangle by dividing the perimeter by the ratio. And then the question said work out the area. To work out the area, I need to do the base times the height divided by 2. So 18 times 24 divided by 2. This will be like, well, 12 times 18 might be easier to do. So 24 divided by 2 is 12. So 18 times 12. This is like 18 times 10 plus 18 times 2. So that's 180 plus 36 is 216. And I would, because this is a non-calculator paper, I would always double check with written working out. So 18 times 12. 8 times 2 is 16, carry the 1. 1 times 2 is 2, plus 1 is 3. And then 18 times 1, or 18 times 10 is 180. And that's just the same operation, but you're just double checking with your working out. So 180 plus 36 is 216. Okay, so final answer there for the area of the triangle, 216 centimeters squared for question 8 for 4 marks. Question 9 has a bunch of indices questions, which are another type of question you shouldn't lose any marks on. So it's important to know and understand your index laws for these types of questions. The first one, part A, says write down the value of 36 to the power of a half. This is the same thing as saying the square root of 36. And for this, we can say the answer is 6. The square root of 36 is 6. You can also say positive or negative 6, but you do not have to because they specify the sign of the number in the question. They say 36 to the power of a half. They don't say negative 36 to the power of a half. Anyways, 6 is also fine for an answer there. Part B says write down the value of 23 to the power of 0. Any number to the power of 0 is just 1. Okay, that's something else you need to know. Part C says work out the value of 27 to the power of negative 213. So when you have a negative index number, that's like saying 1 over that thing. And then 27 to the power of 213, you can think of this as the 2 there in the numerator is 27 squared, and the 1/3 is the cube root of 27. So you could write this as the cube root of 27 all squared, or you could also write this as 1 over the cube root of 27 squared inside the cube root there. Those things are actually interchangeable, or you can write them around. Either way, you still get the same answer, but it's easier, I think, to cube root 27 than to square 27 first and then cube root it. So I'm going to go with this way of writing it. So the cube root of 27, what times itself 3 times equals 27. Hopefully you know that that's 3. So this is like 1 on 3 squared, and 3 squared is 1 on 9. Okay, so final answer there for part C is 1 on 9. And that was question 9 for 4 marks. Question 10 says the table gives some information about the heights of 80 girls. Least height 133 centimeters, greatest height 170 centimeters, lower quartile 145 centimeters, upper quartile 157 centimeters, and the median 151 centimeters. And part A says draw a box plot to represent this information. For this, you need to know what parts of the box plot these pieces of information represent. The median is the middle of the box. That's a line going down the center, or not the center, but that's the line that splits the box in two. The minimum and maximum are the ends of the whiskers, those big long lines coming off the boxes, and the ends of the box are the upper and lower quartile. So if you know all that, then you should be fine drawing out the box plot. So starting with the minimum, 133, let's draw that in, and the scale here is just 1 unit for each line, I believe. Yes, so 133 will be here. Okay, so let's draw in the end of our whisker, and then the maximum is 170, that would be here. Okay, so let's see if we can make this consistent. Actually, let's go all the way. Okay, let's go all the way like this. Yeah. And then we have the lower quartile, that's the end of the box, 145, that would be here. Oops. Okay, and then the upper quartile is the other end of the box, 157, would be here. The median, 151, is there. And then join the box up and draw in the whiskers from the box to the ends. Okay. Alright, there we go. So there is our box plot. On to part B. Part B says work out an estimate for the number of these girls with a height between 133 and 157. Okay, for this we need to know something else about box plots and lower and upper quartiles. So for the quartiles, the lower quartile represents 25% of the people or population of the sample that you've taken. So this whisker is 25% of the sample, and the box represents 50% of the sample. Okay, and this is equivalent to the difference between the lower and upper quartile and the difference between the minimum and the lower quartile. Okay, so the upper quartile, that was this value here at 157. They've asked us to find the number of girls between the minimum of 133 and the upper quartile of 157. So that's 75% of the sample. And how many girls were in the sample? They told us that in the question. There were 80 girls. So this question is actually asking for 75% of 80, or 3/4 of 80 in other words. So we could say this is 3/4 of 80. So 3/4 times 80. And maybe you just know this, or you could work it out. 80 divided by 4 is 20, times 3 is 60. So 60 is 3/4 of 80, or 75% of 80. And then, so our final answer to the estimate for the number of girls between 133 and 157 is 60 for part B for question 10. On to question 11. Question 11 gives us a diagram, and it says A and B are points on a circle center O. BC is a tangent to the circle. AOC is a straight line. Angle ABO equals x. Find the size of angle ACB in terms of x. Give your answer in its simplest form. Give reasons for each stage of your working. So angle ABO they have not drawn in, so let's draw that in now. Angle ABO would be in here. Let me just make that a bit neater. Okay, angle ABO would be in here, and they've called that x. And we're looking for angle ACB, which would be over here, and we want that in terms of x. Okay, the first thing that I've noticed is that this is a radius of this circle, OB, going from the center to the circumference, and this is a radius. So this is an isosceles triangle, and these two angles will be the same. So BAO is x as well. So that's the first thing I'm going to write down. So angle BAO equals x. And this is base angles in an isosceles triangle. Okay, now I almost have all of the angles in this larger triangle ABC. What am I missing? I'm missing this one in here. So I've got this x part of this angle, ABC, but what is this one? Well, for that we can use one of our circle theorems, the fact that a tangent meets the circumference, or meets the radius, at 90 degrees. And if you want more on circle theorems, check out my video going through the proofs of all of the circle theorems you need to know for GCSEs. So anyways, one of them is that the tangent meets the radius at 90 degrees. Therefore, this angle in here is 90 plus x. So we could say then that all of these angles added up should equal 180 degrees. So we could say also that angle ACB is 180 subtract these two angles. So subtract x and subtract this angle here, which we could write as 90 plus x. So 90 plus x. Okay. Oh, and I forgot to write down where we're getting this 90 degrees from. So because it says give reason for each stage of your working, I should write down that angle ABC equals 90 plus x because of the tangent radius theorem. Okay, and then ACB equals 180 take x take 90 plus x. Simplifying this, we will get 180 take 90, which would be 90, and negative x take x, because that negative distributes to both terms in those brackets. So negative x take x is negative 2x. And then we have ACB in terms of x. So 90 take 2x would be my final answer there. So that was question 11 for a total of 5 marks, surprisingly. So I would say not a lot of work there, although maybe slightly difficult to recognize which theorem to use and how to go about answering that one. Just make sure when they say give reasons for each stage of your working that you're actually describing how you're getting the different parts of your proof. Okay, on to the next question. Part 12 says, prove that the square of an odd number is always one more than a multiple of 4. For this type of question, you need to know how to write or how to represent an odd number algebraically. So what algebraic expression can you write that would represent any odd number, no matter what integer you put into that expression? And the way we can do this is to say, well, if you take some number n and multiply it by 2, that will give you an even number. And then if we add 1 to it, we must have an odd number, right? So this is one way to represent any odd number. So we can say we will always have an odd number when we multiply it by 2 and add 1. And we should just specify that n is an integer, where n is an integer. Because you don't want to plug a fraction into this expression. Okay, so we're looking for the square of an odd number. So, well, this is our expression for an odd number, so let's square that then. So 2n plus 1 squared. And then we have some double brackets that we want to expand. So we could write this as 2n plus 1 times 2n plus 1 to n plus 1. And then use FOIL to expand these. So first, 2n times 2n is 4n squared. Outers plus inners is plus 4n, and then last is plus 1. And then you could factorize 4 out of these first two terms, and this would be 4 multiplied by 4n squared plus n plus 1. So this number here, 4 times n squared plus n, well, these are integers, so this is going to be some number. It doesn't matter what it is, but because we're multiplying by 4, this part is always going to be a multiple of 4, as the question says. And then we have that plus 1. So here we've actually shown that the square of an odd number, which is what we did here, the square of an odd number is always one more than a multiple of 4. So we could just state that. So therefore, this is one more than a multiple of 4. Okay. Again, just to be clear, because this part of the expression is clearly a multiple of 4. Alrighty, that was question 12 for a total of 4 marks. Question 13 says, square root of 5 multiplied by the square root of 8 plus the square root of 18 can be written in the form a root 10, where a is an integer. Find the value of a. For this, I would probably start by expanding the brackets. So if we expanded that root 5 to both terms in the brackets, we would get root 5 times root 8 plus root 5 times root 18. And here you want to use some of your surds laws. So one of them says that the square root of a multiplied by the square root of b is the same as the square root of a b. So using that idea, we can multiply the numbers inside the surd. So this would be the square root of 40, 5 times 8, plus 5 times 18, that's 50, plus 40, that's the square root of 90. And then hopefully you can see that you can split these surds up slightly differently. So 40, instead of writing it as root 5 times root 8, we could write that as the square root of 4 times the square root of 10. And the square root of 90, instead of root 5 root 18, we could write as the square root of 9 times the square root of 10. And then we're going to get this root 10 here. The square root of 4 is 2 multiplied by root 10. Square root of 9 is 3 root 10. And then we can combine them because they are like terms. We have that root 10 in both. And this can be written as 5 root 10. So final answer there. For a, the value of a would be 5 for question 13. On to question 14. Question 14 says y is inversely proportional to d squared, where d equals 10 and y equals 4. D is directly proportional to x squared, where x is 2 and d equals 24. Find a formula for y in terms of x. Give your answer in its simplest form. Okay, so inversely proportional, we can write that as y is proportional to 1 on d squared. That's what inversely proportional means. As d increases, y would decrease, and as y increases, d would decrease. Okay, and then we can introduce some unknown to make this an equation. So we can say y equals k on d squared, and we can find the value of k using this information. So when d equals 10, y equals 4, so we would have 4 equal to k on 10 squared is 100. So then k is equal to 400. So then our equation for that first bit of information is y equals 400 on d squared. This is a fairly standard approach to answering this inverse proportion and proportion type question, so I'm hoping you've seen this before. So anyways, let's continue. Y equals 400 on d squared, and they also tell us that d is proportional, directly proportional to x squared. That means then we can say that d, well, let's do this up here, that we can say d is proportional to x squared and d equals kx squared. So by introducing that unknown, we can create an equation, and then they tell us that when x equals 2, d equals 24, so 24 equals x, so 2 squared is 4k, and then k is going to equal 6. Okay, and then we could say, well, plugging that back in, we could say d equals 6x squared. And actually, what we want is a formula for y in terms of x. So we have a d squared down here and a d here. So if we plugged this in and squared it, so 6x squared into here, we could say therefore y equals 400 on 6x squared all squared. It's because this was d squared, this was just d. So hopefully you see what I've done there. And then we've got 400 on 6 squared is 36. X squared squared is x to the power 4. And that should be fine for y in terms of x. I guess we could also simplify, so we could divide by 4. So 4 goes into 400 100 times, and 4 goes into 36 9 times. And there are no other common factors. So final answer there, y equals 100 on x on 9, x to the power 4 for question 14 for 5 marks. Question 15, part A says factorize a squared take b squared. This is the difference of two squares. It's worth knowing about this identity. A squared take b squared, we can factorize to a plus b, a take b. This I think would be hard to work out unless you'd seen that before. But expanding these back out, you see that we get a squared take ab plus ab. Those middle terms cancel out, and we're left with a squared take b squared. Part B says hence or otherwise simplify fully x squared plus 4 all squared take x squared take 2 all squared. Hence here is kind of saying there must be a connection between part A and part B, and here if we thought about this as A and this as B, we have kind of the difference of two squares. So let's see if we can use that somehow to help us solve this. So I guess they're saying we could expand these double brackets out completely, but maybe there's an easier way to do it. So if I write this, if I think about this as A, and I write this as x squared plus 4 plus b, which is x squared take 2, and then multiply that by a take b, maybe this is a shortcut. So let's see, we've got x squared plus 4 take b, which is again x squared take 2. So let's see if this helps us simplify easier. So inside these brackets then, we've got x squared plus 4 plus x squared take 2. So we could say this is 2x squared, and then 4 take 2 is just plus 2. And then x squared take x squared, they would cancel out in here, in the second lot of brackets. And then we have 4 take negative 2, which would be 4 plus 2, which would just be 6. So I guess the point here is then those second lot of brackets, the x squareds cancel out, and all we have to do is expand this 6 with these two terms, which is a lot easier than expanding these double brackets here. So 6 times 2x squared is 12x squared, and 6 times 2 is plus 12. And I believe you can leave your answer as this, or you could factorize the 12 and say this is x squared plus 1. So I think either of those two answers is fine. So I would just write 12x squared plus 12 as my final answer for question 15 part B. And I guess, well, let's just see. So I'm going to do this the long way and just check we get the same answer. And I might just fast forward this bit. So just to show also why this is a shortcut. Okay, so that was the longer method. It's not that much longer really, but I think, yeah, this method would still be classified as a shortcut. Anyways, on to question 16 now. Question 16 says there are only red counters, blue counters, and purple counters in a bag. The ratio of the number of red counters to the number of blue counters is 3 to 17. Sam takes at random a counter from the bag. The probability that the counter is purple is 0.2. Work out the probability that Sam takes a red counter. Okay, if the probability that the counter is purple is 0.2, that's the same as 20%. So I'm going to draw like a bar of probability. You'll see why in a minute. So purple is 20% of this bar. So let's color in that 20% purple. Okay. The remaining probability has to be split up between the red and blue counters in the ratio 3 to 17. So basically what we're doing is we're taking this 80% and we are dividing it into this ratio. So the total parts in this ratio is 20, 17 plus 3, so 80 divided by 20 is 4, and then multiply each part by 4. So actually let me just write down some of that just so it makes more sense. So I've said the total parts in this ratio is 20. I've done 80 divided by 20 to get what one part is worth. That's 4. So this is the same as if I multiplied this by 4, this would be 12 to 17 times 4, 40 plus 28, that's 68. Okay, so this is the probabilities of getting red and blue. So I would split this part up, this 80%, into red was 3 parts, so this would be red, and this part would be blue, and they were 12% and 68%. Okay, so just to answer the question, work out the probability that Sam takes a red counter, that would be that 12%. So the probability of red is 12%. So again, just to reiterate what I did that remaining 80%, given that the purple is 20%, we had a remaining 80% probability and split that up into that ratio 3 to 17. Okay, on to question 17. 17 says simplify fully 3x squared take 8x take 3 on 2x squared take 6x. The first thing I would look to do here is to try to factorize that quadratic. So is it possible to factorize that into 2 brackets? So there are factors of 3 and 3 that would allow me to get to 8. So, well, the only factors of 3 are 3 and 1. So I'm going to have to use 3 and 1. And if I multiply 3 by 3, that would get me 9, and then subtract 1, that would get me, so actually if I have a negative 9 and a positive 1, that would get me negative 8, and then a positive 1 and a negative 3 make negative 3. So expanding these out, we get 3x squared, take 8x, take 3. Okay, so that quadratic has been factorized, and then also we can factorize this expression in the denominator by taking out a 2x, which is the common factor there. So if I factorize 2x, I'm left with x take 3 as well. So then we can see a common factor in the numerator and denominator. It's that x take 3. And I can cancel that out, and then I'm left with 3x plus 1 on 2x, which I believe will be our final answer. There are no other things that we could possibly factor there. So 3x plus 1 on 2x is the final answer for question 17. On to question 18. It says here is a graph of y equals sine x for x between negative 180 and 180. On the grid, sketch the graph of y equals sine x take 2 for x between the same domain as as this graph, this existing graph. Okay, so if we subtract 2 from this graph, that means we shift it down on the y-axis by 2. So if we look at this point, that would be at -2. And by the way, if you want more on graph transformations, check out my video going through all of the things you need to know about graph transformations for GCSEs. There should be a link somewhere on the screen to that. So anyways, if I'm shifting this whole graph down to this point here is at 91, this would now be at 90, -1, and this point here would again be at -2. This point at -1 would be at -3, and this point over here would be at -2. Okay, so once you've got some of those points in, have a go at sketching it. And try to do it neater than this. So one thing I would do, or one thing I do on real paper, is to sketch it in like this with a pencil and then go over it with a pen. So once you've got this sketch in with the pencil, then go over it with a pen nice and neatly, and it gives you, and then you can even erase the pencil markings and it gives you a nice neat graph. So anyways, that is my graph for y equals sine x take 2. For question 18, question 19 says point P has coordinates 3, 4. The point Q has coordinates A, B. A line perpendicular to PQ is given by the equation 3x plus 2y equals 7. Find an expression for B in terms of A. One thing to point out before starting this question is when you look at the equation of a straight line, y equals mx plus c, so I'm sure you've seen this before and what each of these parts of this equation represent. This is the equation of a straight line, m being the gradient, c being the intercept. What this gives us is a relationship between the y and x coordinates. So this is like saying this is an expression for y in terms of x if I'm given the point x, y. So in this question we're given the point a, b, and we're told to find an expression for b in terms of a. This is the same thing. So basically what they're saying is they want us to find the equation for the line PQ. That's basically what they're saying. Find an equation for y in terms of x. Find an expression for b in terms of a. The same thing. So all we really need to do here is to find an equation for the line PQ, and we can start off by finding the gradient because they tell us the line perpendicular to PQ is this one here. And something you should know about perpendicular lines is that they have the gradients are negative reciprocals of each other. So firstly, let's rearrange this equation so that we have it in slope-intercept form, and I'll show you what that looks like. So if we take this equation and we bring that 3x over to the right hand side, so we'll have 2y equal to negative 3x plus 7, and then divide through by 2, we have y equal to negative 3 on 2x plus 7 on 2. This is what we call slope-intercept form or gradient-intercept form. This is the gradient, this is the y-intercept. Then we can say the gradient is negative 3 on 2, so let's just make a note of that. You don't actually have to do this, I'm just kind of doing this for clarity. So the gradient of this line is negative 3 on 2. That means the gradient of PQ is the negative reciprocal of each other. The reciprocal is when you flip the fraction, and the negative, well, that would turn into a positive. So the gradient of PQ is 2 on 3. And then we can say the equation of PQ is y equals mx plus c. Substituting that gradient, we would have y equals to 2 on 3x plus c. And now you need to find c, and you can do that because they give you a point on the line PQ, specifically the point P. They tell you that's 3, 4. So you can use those points, substitute them into that equation and find c. You can do this in a number of ways. I'm going to do it using the point slope form, and that looks like this. So we can say using 3, 4, the point 3, 4. The point gradient form of a straight line is y take y1 equal to m multiplied by x take x1. This is how you find c in a straight line equation. So here y1 and x1 is this point that we are given. So we say y take 4, this point here, y1, equal to m multiplied by x take 3, x1. Also, we can substitute in m because we know that m is 2 on 3. So that's the gradient. And then we expand everything and simplify. So we've got y take 4 equal to 2 on 3 x. 2 on 3 multiplied by negative 3 is negative 2. And then add that negative 4 to the right hand side. So we'd have y equal to 2 on 3 x. Negative 2 plus 4 is plus 2. So we get y equal to 2 on 3 x plus 2. And remember what I was saying at the start. If we're asked for b in terms of a, this is the same as saying y in terms of x. So all we need to do then is to rewrite this equation with b and a instead of y and x. So then we can say, therefore, b is equal to 2 on 3, a plus 2. Okay, and we have our expression for b in terms of a. So we just need to write 2 on 3a plus 2 for our final answer for question 19. On to question 20 then. Question 20 says n is an integer such that 3n plus 2 is less than or equal to 14 and 6n on n squared plus 5 is greater than 1. Find all the possible values for n. The first thing we can start with is this inequality here. 3n plus 2 is less than or equal to 14. We can find an inequality in terms of n here. So subtract 2 from the left hand side, we get 3n less than or equal to 12, and then divide by 3n less than or equal to 4. That's my first inequality. Then we can work with this quadratic inequality, and this is going to give me another set of values for n. So simplifying this, we can multiply by n squared plus 5 on the right hand side. We get 6n greater than n squared plus 5. And then bring everything over to the same side of the inequality, we would have n squared take 6n plus 5 is less than 0. So I've kind of flipped it around and subtracted that 6n from the right hand side. And then we can factorize this. So n squared take 6n plus 5 factorizes to 5 and 1. So this would be n take 5, n take 1. Then we get n squared take 6n plus 5 less than 0. So then you can think of these as your critical values and think of this quadratic, think of the graph of this quadratic. So I usually draw a little sketch to myself. The critical values are the solutions to this quadratic. So that would be 1 and 5. And then because this is a positive quadratic, it's going to be like this. Okay, and this question is saying, when is this quadratic less than 0? So when is it below the x-axis here? And that is between 1 and 5. So when is the graph down here in this part below the x-axis? It is when the graph is between 1 and 5. So the values given from this inequality is, this should be n, not x, because we have the variable n. So the inequality we're given here is n between 1 and 5, greater than 1, less than 5. But also remember the inequality from the first equation, we got n less than or equal to 4. So all of the possible values for n then will be n greater than 1 and less than or equal to 4. We can no longer include that 5 because the inequalities need to be consistent. So n, the first one told us n had to be less than or equal to 4, so therefore these are all of my possible values, n between 1 and less than or equal to 4. So let's go ahead and write that down as my final answer. And just double check I've written or answered the question. Find all the possible values for n, and n is an integer actually, so this is not correct. I'll just rub this out. So if n is an integer, let's write down all of the values. If it's greater than 1 and less than or equal to 4, the integers would be n equal to 2, 3, and 4. So that would be my final answer there for question 20 for 5 marks. And if you are looking for further information on quadratic inequalities, check out my video on quadratic inequalities to go into lots of detail on lots of different questions if you're not sure about this one. So check that video out if you want to. And that was the final question of this paper. The total paper was 80 marks. I hope you found this video useful. Please leave a like if so. Hope your revision is going well. If you're looking for papers 2 and 3, the link to the playlist should be in the description below. And I'll see you in the next one. Bye for now.